2e is a tan graph and tells us the center of rotation as pi over 3 and 2. Gives us asymptotes at negative pi over 3 and pi, and negative slope and vertical expansion of 2. Well, starting with the negative slope and the vertical expansion of 2, we know that a value must be negative 2. Okay, because it's going for a tan graph usually has a positive slope going for it. For the b value, we first need to work out the period, and the asymptotes are going to give us our period. Now the asymptotes are spaced pi apart, so if we normally pi apart, so in this case here the period becomes pi minus pi over 3, and in this case the period ends up being it looks like it's going to be 4 pi over 3. So that being our period, to calculate the b value using the normal spacing of pi, we're going to say that the period is pi divided by the normal period is pi, so we do pi over 4 pi over 3, and that works out to be 3 pi over 4 pi. The pi's cancel out, and we end up with a b value of 3 over 4. The center of rotation gives us our c and d, so we have our horizontal shift and vertical shifts. We have all the parts to be able to write the function. So the function then works out to be y equals negative 2 tan. We have a b value of 3 over 4. Our horizontal shift works out to be pi over 3, and our vertical shift is plus 2. In drawing the graph, we can draw the graph here. We have our center of rotation. We know that we've drawn in our asymptotes here. So when I sketch in this graph, the vertical expansion, or the a value, is negative 2, so it's going to have a negative slope going in this direction. Okay, and since the vertical expansion is 2, we could use the 45-degree coordinates, or halfway between the middle and the asymptotes. We're going to go 2 up here from the center. We're going to go 2 down here from the center, and the graph is just going to follow the asymptotes through that point, through the center, through this point here, and along the asymptotes here. And it's hard to show the vertical expansion, but if you want to show the vertical expansion, normally we would go halfway between the asymptotes and then up one and down one. So in this case here, we're going to go, instead of going up one, we're going to go from the center over halfway and then up 2 to show our vertical expansion. So if we were to show our vertical expansion, which we don't always do, those 2 points here, which I'm going to just highlight here, these 2 points would be able to indicate our vertical expansion, because they would be our normal 45-degree or slope of 1 positions.